Hello dear student, welcome back to classes of maths. Today we are going to discuss first derivative test and second derivative test of maxima and minima. Okay, so this is the topic from calculus class 12 and CRT. Okay, so without wasting time, let's start. So before going to first derivative test and second derivative test, so I remind you about the maximum and minimum value. That means the basic of maxima and minima, which we already discussed. So what we understand about the maxima and minima? Okay, maxima. Maxima means what? We complete this with the help of the graph, and it's very easy. Okay, so if a function, okay, if a function is like that, okay, if a function is like that, and I will draw another function, okay, which is just opposite of like that. Okay, if a function, some function is like here, and this is one more function. Okay, now here at the peak point, the extreme point, we get the maximum value of this function. Okay, and at this bottom, the lowest point, we will get minimum value of that functions. Okay, so at that point means this point is greatest among all neighborhood, greatest among all the neighborhood. This point is the highest point, and this point we will get what? We will get the minimum value of a function. This is the lowest among all other neighborhood point. Okay, so maximum value means what? This, if you get the function like that, okay, then we will get the maximum value at that point. If you get the function like that, we will get the minimum value of that. Okay, so according to definitions, what they are saying, if f be a function defined on an interval, then f is said to have maximum value in I if there exists a point c in such that f of c is greater than f of x. Suppose this is some interval here to here. Okay, so in that we will get the point C, the highest point C, and if the point is like this, greater than f of x, then we will get the maximum value of a function for all, okay, x belong to I. So similarly here, I be some interval of a function, okay, then we will get the minimum value. If there is a point C here, then we will get f of c less than f of x, and for all, okay, x belong to I. Okay, so now in that point, this point we also call the critical point. Okay, critical point, this point, extreme point, is also called the critical point, and this also called the critical point. Now when we are going to find the slope of at that point, slope means dy by dx, that means f dash x, you will get 0. Okay, that also 0. Okay, that all about the maximum and minimum, basic of maxima and minima. One more functions, that is like that. If f said to have extreme value in I, if there is a point C in I such that f of c is either a maximum or minimum value of f in I. Suppose you will get a function like that. Okay, your function is here. Now you will see this function, this, if you draw the function f of x equal to x, like that. That means it's passed through that. For this value, which value is maximum and which value is minimum. So if you take interval up to here, okay, then if you come close to this point, then you will get the minimum value of the function. If you go close to that point, then you will get the maximum value of a function. In that case, the f of c is called the extreme value of a function. Okay, extreme value of a function. Let's see once again what I am saying. I am simply saying that if a graph is like that, and graph is like if a graph is like that, then we will get the maximum value of a function. If your graph is like that, then you will get a minimum value of a function. If your graph is in this way, then we will call extreme value, either it's maximum or minimum. So little I will talk about the local minima and local maxima. What we understand about the local minima and local maxima means, if our graph is in this way, like that, that means in this graph, in this function, our function is this, in this function we will get many maximum point, like that, okay, many maximum point, this, all are maximum point. In that case, if you get the value of the maximum more than 1, then we call local. Okay, similarly, more than 1 value of minimum we will call local minima, local maxima and local minima, and the topmost one is we call absolute maxima or the greatest value, and the lowest most one of that function we call absolute minima. Okay, clear? So this is all about the basic of maxima and minima. Okay, so and also we have to study that some function, okay, in some function we will also get the sharp point, means the function is like that. In that case also we will get a local maxima and minima. This also peak point we consider as the maximum point. Although there is differentiable of this is not possible, then what can we do? We use the graph and we will find the value of maxima. Okay, when the graph is takes sharp turn like this, then the dx is not possible. Then what can we do? With the help of the graph we will able to find the maximum value. Okay, so let's see the first derivative test. So what is the first derivative test? Let's see. All these first derivative tests and second derivative tests are used for finding the maxima and minimum value of a function. So I will give the definitions right hand side of the board, then you will see from definitions from there. Okay, so let's see. First derivative test. First derivative test, what say that if a function f defined on an interval I, then f is continuous at a critical point C in I, then we have a 3 conditions in first derivative test. So first conditions we are going to discuss. Okay, 3 conditions. So first condition, they are saying if f be a function, one function is given. If f be a function in an open interval, okay, if f be a function in an open interval, okay, so my diagram is not so good, you adjust it. Okay, so I will draw the one graph. So which is by looking the graph you have to know that this is maximum graph. So how we find this is maximum? Okay, so although we know this graph is maximum graph, so first derivative test Roman number 1, the first condition says that if the slope of this travel from positive to negative directions, okay, positive to negative direction, then we will get maximum value of a function, okay, or local maximum value of a functions. So slope means what? Slope means in ddx, dy by dx is known as the slope, okay, dy by dx is known as the slope, okay. We already discussed in class 11 the slope in this way, okay, inclination of a line. So we take an angle theta like this from the anti-clockwise direction, theta, then we call tan theta is our slope, okay. Now here also dy by dx we consider as the slope, okay. So when the slope is travel from positive direction to negative, then we will get the maximum value of a function or local maximum value. Let's see, if you will get f of x, f dash x greater than 0, okay, and f dash x less than 0, okay, then you will get maximum value. Let's see, f dash x means what? Slope. F dash x means slope. dy by dx, f dash x here 0, okay. So you know this is the critical point. This is the critical point. In that critical point, if you draw on the slope in this way, then this is parallel to x-axis, okay. When this line is parallel to x-axis, that means the value of theta equal to what? Value of theta equal to 0, okay, value of theta equal to 0. So here this is mean slope tan theta equal to 0, tan 0 degree equal to 0. That means at the critical point, if you find the slope, then you will get 0. Now here, if you take the slope from here like that, okay, I will draw a slope like this triangle theta. Let's take this be theta 1. I will take theta 1. This is theta 1, okay. I will draw a slope in this way and I will take the angle from the positive direction. Then I will get theta 1, okay. And that theta 1 is what? This acute angle. So we know that tan theta acute means tan theta acute angle 0 to 90 degree. There you will get the positive value. Between 0 to 90 degree you will get what? Positive value of 10. So here you will get the positive, okay. So in next case we will get what? Suppose I will draw a slope in this way like that, okay. This is our curve, okay. So this is the slope. Now if I will draw the angle from the x-axis anti-clockwise direction, then tan theta 2 is what? Tan theta 2 is obtuse angle. So we know that tan obtuse, okay, theta 2 equal to gives the negative value, okay. Tan acute theta 1 we will get the positive value. When the slope means this is travel from positive to negative direction, positive to negative, then we will get the local maximum value, okay, local maximum value of a given functions. So once again I tell you, okay, so if the function is, we get like that. So first of all, what can we do? How we find a critical point? Critical point. Let's see how we find a critical point. Critical point. First, suppose some function f of x is given. Suppose 2x square. Okay, 2x square. This function is given. So how we find the greatest value of this critical point of this function? Then we will take f dash x. Then this is 4x. Okay. Now we will take f dash x equal to 0. Now put 4x equal to 0. That means x equal to 0. Okay. This you know that this is a graph of parabola. So critical point x equal to 0. Okay. This is the 0. So critical point, we find that critical point, how to find? We differentiate one time and take f dash x equal to 0 and putting all the value of f dash x here, then you will get the value of x. Okay. So after putting the value of x in f dash x equal to 0, then you will get the critical point of a function. So this is our critical point. Okay. So for number 1 conditions, when the value is travel from negative direction to positive direction, then we will get the maximum value of a functions. For that, suppose 0 is the critical point. 0 is the critical point. Then what can we do? We take one value from the 0, 0.1. That side 0. Minus 0.9. Okay, minus 0.9 we take it here. So one point from there, one from this side we will take and we will put the value. Then we will say that if it's travel from negative to positive direction or positive to negative direction, then we will call maximum value of a function. Okay. So similarly, we go for the next. We go for the next one, that is minimum value. For the minimum value, our condition number 2. Condition number 2 says that what if a function f of function, if a function travel from negative to positive direction, then you will get the minimum value of a function or local minimum value. That means sometime more than 1. So I will draw the graph. Once again, the graph is in this way. Okay. So here at the bottom we will get the parallel. The slope is parallel to x-axis, and from here take one point here. Then you will see this angle is theta 2 we take, and if you take the angle here, then this angle you will take theta 1. Okay. Now let's see. For the first angle, you see this is theta 1. Theta 1. Now you see this diagram. What it's look like? What? It's obtuse angle. Theta 1 is obtuse, and theta equal to 0, and theta 2 is acute. This, if we draw in this way, that is acute angle. Acute. Now we apply that process here also. Okay. So f dash x. F dash x means what? dy by dx. This is dx of f of x. That means f dash x. So f dash x, okay, less than 0 and f dash x equal to 0 and f dash x greater than 0. Now you will see that critical point, this is the critical point. At critical point we draw the slope, then we will get a 0 degree, then this is obtuse angle and this is acute angle. Now tan theta 1 is what? Obtuse. So tan obtuse means greater than 90 degree. If you find the value of tan, then you will get the negative value and this is 0. And tan acute means between 0 to 90 degree we will get positive value, positive. Now when the sign changes from negative to positive, then we will get the maximum value. Okay, we will get the maximum value. So here this you see this negative to what? Positive. We will get the maximum minimum value of a functions. Clear? So first one is about the maximum, second is for minimum. Now in every functions we will not get the maximum and minimum value. Sometimes the function which does not have maximum and minimum value, in that case we will call that point of inflection. Okay, point of inflection or inflection. So here let's see number 3. In number 3, when the function f of function is some curve like that. Okay, so if the sign of f dash x is not changed, means when you travel left to right, okay, left to right, then the sign is not changed. If it's minus, both side minus. If it's plus, both side plus. So in that case we neither get maxima or minima. In that case we will call point of inflection. Okay, points of inflection. If sign does not change, if sign does not change, okay, if sign does not change, then we will get point of inflection. Point of inflection. That means neither maxima and nor minima. Okay, so let's see one functions which is nor maxima and nor minima. So I'm taking from this page number 221 of NCERT book. The function is if you draw the function f of x equal to x cube. Okay, f of x equal to x cube. Now this function, the graph of this function is in this way. Okay, this is the graph of this function f of x equal to x cube. The function of this graph is in this way. So let's see. So for finding the critical point, what can we do? We find the dy by dx. Okay, dy by dx of this function, that is 3x square. Okay, 3x square. Now if you take dy by dx equal to 0, dy by dx equal to 0, then 3x square equal to 0, that means x equal to 0. This is the point. Okay, this is the point, this point is considered as the critical point. Okay, critical point. Now we will see that in that critical point our sign is changed or not. Okay, so our sign is changed or not. So let's see. This is 0. Let me take here, I'll take 1, the value 1, this minus 1 I will take, okay, minus 1 I will take, this is 1. Now let's see, if I will put the value here and here in f dash x, so where the f dash x, we will get what, 3x square. This is f dash x. Now you will see f dash x equal to what, 3x square. Then if you take f dash x minus 1 here, minus 1, okay, this minus 1, this minus 1, then what we will get, 3 minus 1 whole square, that is 3 only, that means positive, okay, minus 1 square is 1 only, that is 3, we will get a positive value. If you take f dash x 1, then this is 1 square equal to 3, which is also positive value. Let's see in the both the case, okay, in the both case I will take one value from the left hand side and one value from the right hand side of the critical point. Then I will see the sign is not going to be changed, both we will get positive value. For this function x cube, f of x equal to x cube, neither give the point of this maximum value and minimum value. So in this type we call point of inflection, okay. So let's see the summary of this first derivative test, okay. So for the first derivative test we have three conditions. Number one is what? Number one is if f dash x change sign from positive to negative, then we will get maximum value or local maximum value of a function. So f dash x greater than 0, then f dash x 0, then f dash x less than 0, means positive to negative, okay. If the sign change from positive to negative, then we will get what? We will get maximum value of a function, okay. Number 2, f dash x. So in f dash x, that means dy by dx, you will get the f dash x less than 0 and f dash x greater than 0. That means the sign change from negative to positive, then we will get minimum value of a function, okay. So if f dash x just opposite, okay, f dash x 0 and f dash x it's greater than 0, so it's negative to positive, then we will get what? Minimum value of a function. Number 3, in number 3, if the sign does not change, okay, then what we will get? We will get the points of inflection. That means we neither get maximum or minimum value of a function, okay. This is all about the first derivative test. So let's take one question from the book, NCERT book. So I am trying to solve one question from example. So many example is given. So let's see one example from, okay, let's take the example 29. Okay, 29. Okay, example number 29. Example number 29. Okay, let's see. Find all the point of local maxima and local minima of a function given by. Okay, so here the function f of x is given, which is x cube minus 3x plus 3. Okay, so find all the point of local maxima. We are going to find the local maxima, okay, or local minima and local minima of a function this. So this is the example number 29 and the page number 222. So solution, we use the first derivative test here to find the local maxima and minima. Okay, local maxima and minima. So our function is here, our function f of x is this, x cube minus 3x plus 3. This is our function. Now we are doing what? F dash x. F dash x is 3x square, okay, minus 3. 3x square minus 3. This is our f dash x. So which is equal to, if you take 3 common, x square minus 1. Okay, x square minus 1. Now we are going to find the critical point. How to find the critical point? Take f dash x equal to 0. Now put the value 3x square minus 1 equal to 0. That means x equal to 1. Okay, and what? Minus 1. The value of x is plus minus 1 we will get from this. Okay, so plus minus 1 the value of x we will get. Now this two are 2 critical point. Now we doesn't know this critical point is for maximum or minimum. Now we check the first derivative test to find it. Okay, let's take the point, first point, the at x equal to 1. We will check that at this critical point we will get maximum or minimum value. Okay, let's see. Now 1, just we take one value from that side, right hand side, one value from the left hand side. So never confuse, for not confusing you draw like this, 1. This is critical point. So I will take one value from there. Okay, that is what? 1.1. Just next value close to 1, then I will take here 0.9, then 10.1. Okay, so one value that is 1.1 and this is 0.9 I will take. Now let's see, at x greater than 1, x greater than, first I will take x less than 1, this side, x less than 1. When x less than 1, then what can we get in f dash x? What is f dash x? This is f dash x. Okay, f dash x. So our f dash x, what the value we will get? When we will take less than 1, then we will get f dash x is, this is less than 1. Less than 1 means if you square it, you will get the value which is less than 1. Okay, so we will get less than 1, then the value is what? Value is negative value you will get. The whatever the value you get, that will be negative. Okay, this is negative, that means 0 is greater than that. That means the function you will get negative. Okay, the function you will get negative when x greater than 1. When the value x greater than 1 you will take, then the function greater than 1. Okay, if you put the square, then you will get what? Positive value. Okay, if you put the square, then you will get the positive value. If positive value, then this is f dash x greater than 1, that is positive. Okay, now you will see, from if you travel from left to right, then you will get what? Negative to positive. So negative to positive. Okay, negative to positive. Then what you get? At point 1 you will get what? Minimum value. Minimum value of function. Okay, minimum value of that functions. So here, sometime by taking this, never be confused. So you will travel from left to right. Okay, you travel from left to right. If you write this here and this here, if you alternate this, then you will see that positive to negative, then you will write maximum. No, it's not like that. So you will check it first. After finding the critical point, you travel from left to right. Okay, left to right, then you will get the proper. Otherwise, don't take jumbly. Okay, you take this first and take this second, then you will get another value. Okay, so you travel from left to right. Now we will see, you will see at minus 1, at x equal to minus 1, at x equal to minus 1, what the value we will get. Okay, now minus 1 is our critical point. Okay, minus 1 is our critical point. Left hand side, just take minus 2. Okay, and the right hand side, we have next point is 0. If you take greater than, if you take 1, then it's also okay. Okay, 1 it's also okay. So, but we have to travel left to right. So I'm ignoring to take this point, that's why I will take the solid value. So this is our f dash x when x less than minus 1, that means minus 2 we will take. Okay, when x is minus 2 we take, means more than less than minus 1, minus 1 is greater, the value of x is less than minus 1, minus 2, minus 3 and all the minus we take. Now f dash x, therefore f dash x, so f dash x is this. So if you put here minus 2, then minus 2 square, it's 4 minus 1, you will get what? Positive value greater than this minus 1 or greater than 0, you will get the positive value, that is positive. Clear? Now we travel that side. Okay, we travel that side. If you take greater than this, minus 0.9. Okay, so if you take minus 0.9, then next value I'll take minus 0.9, then it's minus 1. Okay, minus 0.9. If you take minus 0.9, then you will get less than 1. Okay, if you get less than 1, then what? Then the function is negative. F dash x is less than 0, that means negative. Now it's travel from positive to negative direction. Okay, now it's travel from positive to negative direction, then what? Maximum value maximum value of a function we will get. Okay, so at the point 1 we will get the minimum value, at the point -1 we will get the maximum value. And take care while solving this system. Okay, we will take one value from the left hand side of the critical point and one value from the right hand side of the critical point, and we travel always left hand side to right hand side, then we will get the proper result. Okay, so this is example number 29 about the local maxima and local minima. So at point 1 we will get the local minima and point -1 local maxima. Okay, so now we will see the second derivative test. Let's see the second derivative test, and this is also very easy. Second derivative test. Second derivative test. In the second derivative test, okay, so I'll draw in the graph first. Suppose this is the function. Okay, and this is the function. So here some critical point in the interval I. So we have a function f of x, and this is the critical point in the interval I. So in the second derivative test, f of x is the function. So what the second derivative test says that if a function defined on interval I, and there is a point, some point C which is belong to I, okay, C belong to I, then f is twice differentiable at C. Means whatever the value critical point, at that point we have twice differentiable, 2 times second order derivative we do at that point. Okay, we do at that point. That means first we will do f dash x, okay, and f double dash x at what? At the given point C, at the given point x equal to C, which is belong to I. So they say like this. So in second derivative test, what can we do? Let's see. Number one. So first of all, we do f dash x. Okay. We do f dash x of the given function f of x. After that, we will do second double dash, means second order derivative at the point C. So C is differentiable at second order derivative, otherwise we not able to take second derivative test to find the maxima and minimum value. So if you put the value f double dash C, okay, if you put the value at second order derivative at C means the critical point, then if you get less than 0 means negative value, then we call maxima. Okay, so once again I know you all are not understand, so let's see once again. So what I am saying that f of x be a function in interval I, and there is a point C which belong to I, and at point C there is possible of second derivative. Okay, at C we able to do the second derivative, then we will find the maximum and minimum value of a function. So at point C, what can we do? Number one condition, f dash x, that means the slope. Okay, f dash x means the slope. Then after doing the f dash x, we will get the slope by putting it 0. And again, what can we do? We do double dash x, that means the second order derivative. So at the point C, if you will get less than 0, okay, that means the negative value, then you will get the maximum. Okay, now number 2, second condition. If your second order derivative at C, this is also at C, f dash x equal to 0, if you do like this, then you will get the critical point. If you get f double dash x greater than 0, positive, then you will get the minimum. Okay, so you try to understand. When you will get in f double dash x, okay, negative value, then you will get the maximum. Positive value, then minimum. Negative, maximum, positive, minimum. Okay, positive value, then minimum. Where? Second order derivative. In second order derivative, you get positive, then minimum. Second order derivative, you get negative, then maximum. Okay, so like this, dx square less than 0, this is second order derivative, negative, then maximum. Second order derivative, this is greater than 0, then minimum. Clear? Now number 3 is, in number 3, if you will get second order derivative equal to 0. Okay, so this is first order derivative, first, second, if you get negative, then you will get maximum. Then if second order derivative positive, you will get minimum. And what if you get dy by dx equal to 0? When the dy by dx equal to 0, then we not say it's maximum and minimum. Then what can we do? We will go for again the first derivative test. Okay, we see the slope. If the slope is same, means not changing their sign from positive to negative or negative to positive, then we call points of inflection. If that is other change the sign, then we will say that this is maximum or minimum. So when you get d square y dx square equal to 0, then we will go for the first derivative test. Okay, go back to the first derivative test and you will see once again with the help of the slope. And we also another process, higher order derivative, to solve this type of question, but this is not in our syllabus, so we not study the higher derivative test. We study the first derivative test to find in case you will get this equal to 0. Okay, once again I repeat it. Let's see. So let's see. Condition number one. If you get the value of this negative, then we call it maxima value of a function. local maximum value of a function you will get. Okay, if you will get the value dx square greater than 0 and we call it positive, then we will got minima. Okay, number 3 is, you see the definition from the right hand side, clear? Number 3, if you will get dy by dx equal to 0, okay, dy by dx square equal to 0, then we go for the first derivative test. Clear? First derivative test. So we will solve one more question with related this second derivative test. Okay, so let's see the question which we will solve with the help of this second derivative test. Second derivative test is easy to find the maxima and minima. So most of the question we solve by the second derivative test. Okay, so if in question there is not mentioned, you solve from which derivative test. Okay, so let's see example number 33. Example number 33. If you see the page number 224 of NCERT book. So find all the point of local maxima and local minima of a function f given by. So here the function is given f of x equal to, okay, f of x equal to 2x cube minus 6x square plus 6x plus 5. This is f of x. F of x equal to this 2x cube minus 6x square plus 6x plus 5. So in this function we are going to find all the point of local maxima and local minima. Okay, local maxima and local minima of the function. So first of all we find f dash x. So solution. So here the function is this. We find f dash x means the dx of f of x. So which is equal to 6. 3 into 2 6x square minus 12x minus 6. Okay, this is f dash x we will get from this function. So we will take 6 common, then this is x square minus 2x, this plus 1, no? Plus 1, okay, plus 1. So this is directly what we will get, x minus 2, x minus 1 whole square. So we will get x minus 1 whole square. Now we are going to find the point the critical point first, no? F dash x. First we are going to find f dash x. Okay, f dash x directly I will find from there. So that is, if I am going to find f double dash x, then this will be 12 x minus 1. X minus 1. Okay, this is f double dash x. Now take f dash x equal to 0. Now we are going to find a critical point. So this is 6 x minus 1 whole square equal to 0. That means x minus 1 equal to 0, x equal to 1. Okay, x equal to 1, we will get the value x equal to 1. Now we will see at x equal to 1, what value give? This f double dash x value is positive or negative, or is 0. Okay, so now put x equal to 1 in f double dash x, then what we will get? F double dash 1 equal to 12, and this is 1 minus 1. Okay, 1 minus 1, which is equal to where we put here 1 minus 1 equal to 0. So what we will get? F double dash x is equal to 0. So if you get f double dash x is equal to 0, then we will not say that 1 is okay, 1 is what? The point 1 is neither maxima and minima here. So for finding this maxima and minima, where we go? We go for first derivative test. Now if we are going to find the maxima and minima, then we will go for first derivative test again. So by first derivative test, by first derivative test, now we are going to find x equal to 1 is a point of maxima or minima. Okay, so in first derivative test, what can we do? We will put the value one value from the left hand side, one value from the right hand side of the critical value. So we know that x equal to critical value, x equal to 1. At x equal to 1, so this is 1, this is 1.1 I will take, this is 0.9. Okay, so if I will put 0.9 here, okay, 0.9 here, then what I will get? F dash x. Okay, if I will put 0.9 here, then I will get negative value. If I put square there, then I will get the positive value. Okay, if I will put this minus value here, then also it's minus, and if you put the plus, then we will get the positive value. So what we will get? We get positive value when x is less than 1. Okay, we get positive value when x is less than 1. If I will take, this is also positive when I will take x greater than 1. If I will take the greater than 1 value, 1.1, then also I will get the positive value. Now you will see that when I travel from left to right, both the time we will get the what? We will get the positive value. That means the sign never going to be changed. So what can we understand? That when sign is not going to be changed, then we call that point of inflection. So x equal to 1 is what? It's a point of inflection. So it's neither maxima and nor minima. Okay, so it's called x equal to 1 is the points of inflection. Okay, point of inflection. So let's see one more example. Now I will take the example number 32. Example number 32. Example number 32. Let's see. Example number 32. Example number 32. So function is given f of x. F of x equal to 3x to power 4 plus 4x cube minus 12x square plus 12. This is example number 32. 3x to power 4 plus 4x cube minus 12x square plus 12. So this is the function. Now here we are going to find the local maxima and local minimum value of that function. Okay, local maxima and local minimum value of the function. So let's see what can we do. We are doing f dash x. F dash x is 12 x to power 3 plus again 12 x square minus 24x. So we are taking 12 common. Okay, 12x common. So let's see, we are taking here what 12x common, then what we will get, x square plus x minus 2. Okay, plus x minus 2. Yeah, correct. So f double dash x, also we are doing f double dash x. Then this is 3 to the 6, 36x square. Then it's 24x minus 24. This is f double dash x. Okay, f double dash x, 36x square, 36x square, 36x square plus 24x minus 24. This is f double dash x. So okay, now we have find our critical point f dash x equal to 0. Take f dash x equal to 0. Now we are going to find the all critical point of this function. This is 12x x square plus x minus 2 equal to 0. Okay, minus 2 equal to 0. That means either this equal to 0, this equal to 0. So 12x, this if you solve this x square plus 2x minus x minus 2 equal to 0. Then what we will get, 12x x square. If you take x common, then this is x plus 2. If you take x common, then minus 1 x plus 2. Okay, which is equal to 0. That means 12x and this is x minus 1 x plus 2 equal to 0. That means we will get the value of x equal to 0, and from here we will get 1 and minus 2. So these are the critical point. 0, 1 and minus 2 are the critical point. Now we put the value one by one here, and we will see that f double dash x is positive, negative or 0 or not. If we will get the positive value, then we will say minimum. If we will get the negative value, then we will say the maximum. Okay, if we will get double dash x equal to 0 after putting this value, then we will go for the first derivative test. Let's see. Now when I will put x equal to 0 here, at x equal to 0, okay, f double dash x, what we will get, f double dash x, what we will get, we will get this 0 and this 0, then we will get minus 24. Okay, minus 24 means f double dash x, it's less than 0. That means negative. Okay, so negative mean maximum. So at x equal to 0, f of x, what? F of 0 get maximum value. So maximum value we will put 0 here. Okay, at x equal to 0, what we will get? Maximum value, because negative then maximum. Okay, then f 0. So maximum value we are going to find. Therefore maximum value maximum value f of 0 equal to, we put 0 0 0, then what we will get, 3x to power 4, this is 0 to power 4, okay, then what, plus 4 0 cube minus 12, this is 0 square plus 12, then we will get 0 plus 0, 0 plus 12, we will get 12. Clear? So let's see. So what can we do? We pick up one value from here and we will put f double dash x in f double dash x. If you will get a negative value, then we will say that maximum. We will put another value 1, then you will get, if the positive value, then we will say that minimum value. Okay, like that we solve 1 2 3 in the same manner. Okay, once again I explain this example number 32. So let's see, f of x is given, this is given function. So they ask about find the local maximum value or minimum value of that function. So what can we do? We differentiate, that means f dash x. After doing differentiating, we get like this. So differentiating, and I am taking 12x common, then remaining one is this. Then what can we do? I differentiate 2 times. This time I will directly differentiate from here. Okay, so if I differentiate here, then little bit you confused. That's why I will take directly from above. Okay, directly from here. Okay, then I will get in this way. And after that, we know that we need the critical point. So how to find a critical point? We put f dash x equal to 0. Okay, we put f dash x equal to 0, then we will find the value of x. After putting the f dash x equal to 0, you find the value of x. All the point of value of x are known as the critical point. That critical point we are going to put in f double dash x. First I will take the value of x equal to 0, then I will put in f double dash x. F double dash x means this. Okay, f double dash x is this. Then I will put it here, then I will get it's 0. Okay, I will get it 0. Then 0 means negative. Negative means in second order derivative, negative means the maximum value. Okay, maximum. So maximum value of that function I will put in the main function. Then I will get 12 is our maximum value. Okay, so similarly we solve 1 and minus 2. So you solve this question. So before completing today's class, just summary, you see the summary of today's class. So today we study about the first derivative test and the second derivative test, and both are used for finding the maximum and minimum value of the given function. So let us say the summary. Okay, so we know that when the graph is attained like this, okay, then this point is maximum point, and we also call that point as a critical point. This point is a maximum point of a function, and if you find a value at this point, then we will call maximum value of a function. Okay, so if you get the graph in this way, then this point, the lowest of every point, we call the minimum point of that function. So this is a function of the sum graph. So this point which is lowest of every point in his neighborhood, then we will call maximum point. If you find the value of this point, then we will call maximum value of that function, and this also we call the critical point. So how to find the critical point? So suppose this is a function. Okay, this is a function, then critical point we will find df of x by dx equal to 0. So if you put all the value of f of x equal to 0, then you will get the critical point of the function. Okay. So after that, when you get the graph like this, okay, so here is some point you have. Suppose I take this point B F. So now this graph is quite it's not like maxima and not like minima. So in that case we called it extreme value in I. Okay, so an extreme value of f, suppose this is a function, nearly this type of function is y equal to x. If you see the function of y equal to x means f of x equal to x. So this type of function you will get the extreme value in f. So when you travel to this point, when you travel like that, means left to right, you will get the maximum point. When you travel this from right to left, you will get the minimum point. So you will see this is so at the same graph we will confuse which one we will take. We will take this or this. Okay, if you take this, then we will call the minimum value. If you take this, then we will call the maximum value. So in that case, when you have going in the both direction, maximum direction and minimum direction, then we call that as extreme value in f. Okay, so after that the first derivative test means, so before first you have to understand the local. So when this graph is like this point is local maxima and minima, and this point is called absolute value of a function, and this called absolute minima, this is absolute maxima. Now first derivative test and the second derivative test. First derivative test. So in first derivative test, what can we understand? So when f of x is greater than 0, f dash x is greater than 0, and f dash x equal to 0, and f dash x less than 0. When the function move from positive to negative, then we will get maximum value of a function. Number 2 is just opposite. F dash x less than 0, f dash x equal to 0, and f dash x is greater than 0. That means negative to positive. So negative to positive, what we understand? Minimum value of the function. In that case, maximum value of a function we get, or maximum value, or more than one maximum value, that is local maximum value. This is minimum. Okay, so when the sign never changes, sign of f of dash, sign never changes. Okay, that means both the direction, either you get positive to positive, or negative to negative. Then we not get maximum or minimum, then we call that point is a point of inflection. This is first derivative test. Second derivative test. In second derivative test, what can we do? We are doing f dash x, okay, equal to 0. F dash x equal to 0. From here we find the critical point. Okay, again we find f double dash x. After finding the critical point, if this f double dash x is greater than 0, that means the positive. Okay, if it's positive, then we get minimum. Okay, our first condition according to our book it's given negative, like that, then negative, then it's negative, then we will get maxima. If f double dash x we will get positive, then we will get minima. Okay, if f double dash x equal to 0, then we not say about the maxima and minima. Okay, and we not directly say point of inflection. In that case, we will go for the first derivative test. In the third case, we again move back to first derivative test. In first derivative test, if the sign does not change, then we will say that it's maxima and minima, okay, or point of inflection. Okay, so if f double dash x equal to 0, then this is decided by first derivative test. Okay, so this all about the theory of maxima and minima. Okay, so we have to discuss some of the important example of the textbook, and we are going for our last exercise, that is exercise 6.5. we are going to solve some of the question of exercise 6.5 in next class. Okay, so all of you, if you have any doubt, any problem, any query regarding mathematics, okay, regarding this topic or other topic, you have to intimate me. I am trying to solve your doubt. Okay, so that's all for today. So one more thing I am going to discuss. So here I am not habituate directly come in front of camera and speaking. So this make me so means it's so awkward. I am not able to teach like that, and I am not a YouTuber. I am a just simple teacher. So without student, the big class, no student, I am alone. Just in front of me, one mobile is there. Nothing is speaking, no disturbance, nothing. This feel very awkward to take class. Okay, so I am sometimes little bit nervous to come in the camera, and from the very beginning, from means my teaching career, I am never faced a camera. Okay, I am regularly go to class, I interact with student, I talk with student properly. I means in this way I am not happy to take class like this. So without a student, its class is not nice. Okay, so what can we do? We have no option. We have no option to teach. Okay, so that's why I boundedly come to in front of camera and recording. Okay, so sometimes my voice is not clear. Sometimes this is what I am calculating. This is little bit mistake, and there is no student to questioning me also. Okay, so we have nothing to do in this pandemic situation. So I play this class is very awkward. Okay, very awkward without a student. This I am not feel nice to teach. Okay, lastly, take care all the student wherever you are from. No? You are from in our locality or other place, or from every side. They all coming to our school in same class. So we are enjoying a lot in class and study as well as means playing. All this we are doing. So now it's a very problem. Okay, So this pandemic situation, this due to this COVID-19, this not only our school, the all school of world are suffer. Okay, so we are one of them. So at last I prayed to Almighty God, then your health be nice, okay, and take care, stay safe, stay home, and practice mathematics, okay. Then thank you. So if maths teachers give lectures that's not feel nice, okay, thank you and have a nice day and study, okay, bye.